Intermediate Algebra for Statistics, Using Factoring to Make Predictions with Quadratic Models, Part 4. Looking Ahead, Quadratic Form. In this video, we will look how the values of a, h, and k in the form y equals a times the quantity x minus h squared plus k will change the graph of y equals x squared. So we first will begin by using what's called the z-square on the graphing calculator. The graph y equals x squared. So we type in x squared and y1. We hit graph. Then if we hit zoom and number 5 for zoom square and then hit graph, this is now x squared. So because this is a rectangle viewing window, the x and the y's are at different scales. So using the z-square, it makes the x unit and the y unit the same on both axes. Graph these equations in the form of y equals x squared plus k in order. Y equals x squared plus 1, y equals x squared plus 2, y equals x squared plus 3, and y equals x squared plus 4. State in terms of k how you would move the graph of x squared to produce each graph. Do the same with these equations. Y equals x squared minus 1, y equals x squared minus 2, y equals x squared minus 3, and y equals x squared minus 4. So for the first one, y equals x squared plus 1. This is now the graph. Y equals x squared plus 2 becomes this graph. Next, k is plus 3. We have this graph. And the last one, when k is a positive 4, we have this graph. So we would say when the value of k is added to the x squared, the graph translates, and that's a fancy way of saying slide, vertically up k units. Let's do the next 4 graphs. X squared minus 1 produces this graph. X squared minus 2 is this graph. When k is a negative 3, we have this one. And the last one, x squared minus 4, the y-intercept now is a negative 4. So we say when the value of k is subtracted from x squared, the graph translates vertically down k units. Now let's look at h. So we will graph these equations. Y equals x minus 1 quantity squared, x minus 2 quantity squared, x minus 3 quantity squared, and x minus 4 quantity squared. And we want to see how the value of h is changing y equals x squared. We will also look at values of h being negative, because when h is negative, we have x minus a negative number, which becomes plus. So for this graph, h is a negative 1, h is a negative 2, h is a negative 3, and h is a negative 4. So for the first graph, make sure you use parentheses. We have x minus 1 quantity squared, and that gives us this graph. X minus 2 quantity squared gives us this graph. The next one, and x minus 4 quantity squared is this one. So the x-intercept has moved from 0 to positive 1, positive 2, positive 3, and in this case a positive 4. So when the value of h is positive in the form of x minus h quantity squared, the graph translates horizontally to the right h units. Let's see when h is negative. So we have x plus 1 quantity squared. So in this case, h is a negative 1. This is the graph. When h is negative 2, we have this graph. Next. And then the last one. When h is a negative 4, now we have an x-intercept of negative 4. So you would say when the value of h is negative in the form of x minus h quantity squared, the graph translates horizontally to the left h units. Next, we will look at the value of a. So we will graph y equals 0.1x squared, y equals 0.4x squared, y equals x squared, which in this case a is 1, y equals 2x squared, a is 2, and lastly y equals 5x squared. We will also look at negative values of a and see how that affects the graph. So let's begin. So when a is equal to 0.1, we have this graph. When a is 0.4, we have this graph. When a is 1, we have this graph. When a is 2, we have this graph. And when a is 5, we have this graph. So there are two things going on here. All these values of a are positive. So when the value of a is positive, the parabola opens upward, and the larger the value of a, the more narrow the parabola. The smaller the value of a, the wider the parabola. Let's look at negative values of a. When a is equal to a negative 0.1, we have this graph. When a is a negative 0.4, we have this graph. A negative 1, a negative 2, and a negative 5. So when the value of a is negative, the parabola opens downward. And also, the larger the absolute value of a, the more narrow the parabola. The smaller the absolute value of a, the wider the parabola. So we have seen how a affects x squared, how h affects x squared, and how k affects x squared. Our last series of graphs, we will look at y equals x squared, y equals 2x squared, y equals negative 2x squared, y equals negative 2 times the quantity x plus 1 squared, and the last one, y equals negative 2 times the quantity x plus 1 quantity squared minus 6. And we will look at how the value of a, h, and k affect the graph of x squared to produce each graph. So for the first one, y equals x squared. So in this case, a is 1, k is 0, and h is 0. When we look at 2x squared, a is 2. So that is going to change the graph and make the parabola more narrow. When we do negative 2x squared, since a is negative, the parabola is going to open downward, but it will have the same steepness as the second graph. Next, when h is a negative 1, that is going to move the graph horizontally to the left 1. And the last graph, when k is a negative 6, it is going to take this parabola and move it downward 6 units. So let's summarize. For the values of a, when a is greater than 0, a positive number, the parabola will open upward. When a is less than 0, which means a is negative, the parabola will open downward. The larger the value of a, the more narrow the parabola. For h, when h is positive, it translates to the right, and when h is negative, it translates to the left. The only tricky part about this is when h is negative, this will be x plus h. And for k, when k is positive, it translates up, and when k is negative, it translates down. Thanks for watching.